Hello everyone and welcome to the Advanced Programming webinar. My name is Matt Burkle. I was in First Leg League from 2005 to 2007, and ever since then I have been involved with volunteering as a referee, as a roulette design judge, and I've also helped out teams, and I've been giving these software training sessions. I hope you guys found the programming basics session useful. This session is designed to build on top of that, so we're going to get into some more advanced topics. Yeah, let's go ahead and get started. So the first topic that I want to cover is a general idea. It's not a specific block, and that topic is this idea of data wires. So I'm going to pull out a few blocks here. They don't necessarily, don't worry about what they do right now, but just to show you what the data wires look like. So you'll see some blocks, some of these newer blocks that we're going to talk about, have a plug on them that can be clicked and dragged around like this. This here is called a data wire. And this data wire is used to transfer data from this block here into another block. And so there's a few different types of data wires. This one here, you can see the plug has a triangle on it and it's green. That means that this is a Boolean data wire, which can just be two different values. It can be a 1 or a 0, a true or false. And so that's a green data wire. Another example here is a yellow one with a round plug. This one is a number, and it can be 0, 1, 2. It can be anything like that. It can also have decimal values. So these are yellow and they have round plugs. That's a number one. And the third example is right here. This one is a text data wire. It has a square plug and it's red. We don't use these too much for First Lego League, but just so you know what they look like, there's red data wires too. And so like I was saying, those data wires are used to transfer data, or a number value or a true or false value from one block into another. And so you see these are the plugs. And some blocks have plugs, and you'll notice that a lot of the other blocks that we looked at before, they have sockets. And so you can actually use data wires to control or change the settings of just about any block. So I could drag and plug this in here, and so now this value that's coming from this block is going to override whatever I had manually typed in to this move block before. Now, again, what I'm doing here doesn't really make sense. I'm just showing you the data wires as an example of how you could drag and plug them in. Generally, these wires try to auto route themselves around the blocks. You can still, even though it's not obvious that you can select and click them, you can click and drag the wires if for some reason it's not routing them correctly, and you want to make it easier to see, so you can drag these around by just clicking on the wires. If you want to disconnect a wire, all you have to do is grab the plug, bring it back into space here, and just let go of the mouse. So that's how you delete the wire. And one other thing too, it is possible to have data wires plugged into to select the port number. You just have to change it up here to this symbol of a data wire plug. And so now you'll see a new port slot has appeared here, and I can control the port of this move block with a data wire as well. So you have that option too. There are some other blocks that we've looked at too that can be controlled with data wires in some interesting ways. So I just showed you the move block, and if you look at just about any of the blocks that we talked about, they'll have ways to be controlled with data wires. So a couple good examples, if you look at the switch block here, at the beginning of the loop, if you look at the loop block here, at the beginning of the loop, there is this plug here. This one represents the current count of the loop. And so this could be used for some interesting, I've seen it used for acceleration routines, where a team takes this and does some math with it. Maybe they multiply it by a number, or they just simply use this as their motor power value in order to get a custom acceleration setup with their motors. You can also have the loop stop based on a logical condition that's provided with a data wire. If you change here the setting to logic. And so here you could have some other algorithm that computes some value with some data wires, and then you could have that true or false calculation be what ends this loop. The switch also can be controlled with data wires. So you'll see here that you can plug in data wire here, but probably the one that would make more sense is to switch this to a logic. So you can provide some interesting logic values for your switch, and it will do the top section if that logical statement, that logical calculation is true, and the bottom section if that logical calculation is false. Interestingly, you can also provide it with a numeric data wire, and when you do that, you can actually have more than just two options. Before, when we were using the switch, we just did one of two things. We either did, when the line was black, we turned one way, and then when we saw white, we turned the other way. Or if the touch sensor was pressed, we did one action, and if it wasn't pressed, we did another. If you use the numeric setting and you provide some number here, you can actually hit this little plus button, and it will add another case down here. And so you could make this, you could have case 1, and you could have case 2, and you could have case 3. And then based on what is provided in this data wire plug, the program will go through one of these 3 different paths. This is actually most useful if you're trying to make a mega program that has all of your different mission runs in it, and you can put a different mission run in each one of these, and then based on some inputs like the buttons that you press on your EV3, you can tell your program to come down one of these 3 paths, and that way you have all of your programs downloaded onto your EV3 in one mega program. Another block that we talked about, which can use data wires, is the display block. So if you change this to text, and then up here you select wired, you can actually display some value from a sensor or anything you really want on the screen via this data wire hub. So that can be pretty useful if you're trying to read information on the screen while it's happening when you're trying to run a test at home. Really great for displaying sensor values on the screen. You can also use data wires with my blocks when you're creating them. And so I will just go ahead and make a simple my block as an example. So when you're in this my block builder, if you click right here where it says add parameter, you can actually create a custom data wire input to your my block. And so if I just do test here, it's a number input there, and then I click finish, and I go back to my program here, you can see that the my block actually has now a data wire plug. If I double click that my block, you'll see that that parameter, that data wire, is now represented. This is, remember, now I'm looking at the my block. It's now here in the my block, and I can read that parameter in. Let's say, that parameter was for the port. I'd plug that in right there. And now my block from the outside gets the port from here. All right, now let's talk about some new blocks. So we've covered data wires, and we've looked at how the old blocks that we talked about can use data wires. Now let's move on and talk about this next palette here. It's called the sensor palette. These blocks are all used to read sensor values. It's important not to get these confused with the wait block that we talked about before. The wait block is used to wait until a sensor reaches a certain state. So you could wait until the touch sensor is pressed. We've done that before. That's much different than reading the value of the touch sensor. So this is a touch sensor read block. This is a wait block. This read block gets the value of the touch sensor and gives that value to you on this data wire. You need to tell it what port number to read from, and then you're telling it to measure state. Similarly, we can read, the value of the color sensor. We need to tell it what to measure. So generally we would measure reflected light intensity, tell it what port number, and that reflected light intensity value will be here on this data wire. We also have the rotation sensors that we can read separately. Now, yes, your move blocks, remember, they'll already allow you to turn on for a number of degrees or rotations. Those use the built-in rotation sensors, the same rotation sensors that you can read independently using the sensor blocks. So you can read those values if you wanted to do some calculations with them by using a sensor block. Again, select the port number. You can use the infrared sensor. I haven't downloaded the block, but you can download the block, or I think if you have the educational kit, it will already have it for the ultrasonic sensor. So you can read the ultrasonic sensor just like you can read these other sensors using the sensor block. The last important sensor block down here is called the timer block. Now there are built-in timers that are inside of the EV3, and there are 8 of them. And these timers, as soon as your program starts, all of the timers by default will begin counting. And so whatever the value is of the timer will be here on this data wire. If you wanted to read the timer from, basically start the timer in the middle of your program, then you need to bring out one of these sensor blocks. So actually I'll do a little example here. So let's say, we drove forward and then we made a turn and then we wanted to start the timer and then we wanted to do some stuff and then we wanted to measure how long that took. So we would simply need to use this reset feature on the sensor block. So this resets timer 1 at this point in time. So even though timer 1, just like all of the timers, started right at the beginning of the program, and it was running, then we reset it back to 0. We did this action, and then we measured the time from timer 1. So that's, if you want to measure something in the middle of your program, you need to remember to reset that timer beforehand. Oh, and also similarly, I forgot to mention this, these rotation sensor, read rotation sensor blocks act the same way as the timer. So there is also a reset feature in the rotation sensor block, and the rotation sensor starts counting as soon as the program begins running. And so again, if you had some move blocks here and you drove and you turned and then you said read, now remember these are BC, BC, so let's say we said read from B, this would not be 0. This would have whatever it accumulated through the program up until this point. Now, if I put reset rotation sensor B right here in the program, then it would drive forward, for this one rotation, and then it would turn here and we would get the value that B had accumulated just on this move block in the middle here. And just it is okay. These move blocks don't mind if you reset your rotation sensor in the middle. It's definitely okay to do that. These blocks, the move blocks, are smart enough to figure out, what's the value right when I started this move block, and I need to move it for one more rotation beyond that. So if you're resetting the rotation sensor count in the middle, that with these sensor blocks, you're not going to break anything with the move blocks. So that's good. You don't need to worry about that. All right, and one last thing to point out too, with these sensor blocks, there is a way to read the brick buttons. And so you can read which button is pressed on the EV3 using this data wire. That might be an interesting way, like I was mentioning earlier, where you could have all of your programs in one giant program using a big switch. You could read the button here and have different programs correspond to different buttons on your EV3 brick. So this would be one way to read that. All right, so those are the sensor blocks. Now let's move on to the next palette. It's called data operations. So just a quick summary, the sensor palette let us read numbers or values from our sensors and get those values on data wires. The data operations palette lets you do something with those data wires. It lets you do math or let you do calculations in order to come up with some kind of algorithm using the values that you have read. So let's start off with the logic block. This logic block lets you perform logical operations on inputs. And so you have two logical inputs. You'll see they're triangles here. They're for logic or green data wires. And the output is also going to be a logic. And so if we click here on the primary setting, we can see we have and, or, XOR, and NOT. The easiest way to understand how these operations work is to look at that little Venn diagram that's displayed here on the block. And you'll see in the current setting here, I have it set to and. Only the space between the circles for A and B is filled in dark. That means that this output will be true if both A and B are true together. But since the space for just A is not filled in, and the space for just B is also not filled in, if only one of these two happens to be true and the other one is false, then this output will also be false. If you see, if I change this to OR, now the space in between A and B is filled in. The A circle is filled in on its own, and the B circle is also filled in on its own. So now, if both of them are true, A and B, then the output is still true, just like before. But now if just one of the two of them is true, even if the other one is false, the output of this operation will be true. So that's the logic block. You can use it for these logical operations, such as, if you had two touch sensors here, you could say, oh, are both touch sensors, touch sensor A and B, pressed? So you would grab two touch sensor blocks and connect them like this. You need two separate touch sensors. So now the output of this will be true if at this moment both touch sensor 1 and touch sensor 2 are pressed, because I'm using an AND operation. I could switch it to an OR, and then the output of this would be true if one of those two touch sensors is pressed. It doesn't matter if one of them is released, as long as at least one of them's pressed, then the output of this logic block will be true. Next up, we have the math block. The math block lets you perform basic mathematical operations as well as some advanced stuff. So you can do add, subtract, divide, multiply. And you can, I forgot to mention this before too, on the logic block, you can provide values if you want, just like you always did with, like the move block. You can still click on here and type or change these values manually. Or you can provide the values with some kind of other block. So if we wanted to add two rotation sensor values up, we could do that. We'd just plug them in here. Now it's going to add these two rotation sensors and give you the answer on this block. An interesting use of this math block is the advanced setting down here. Now this advanced setting, when you click it, it gives you 4 plugs, A, B, C, and D, and if you click this equation setting up here, you can actually type in whatever equation you want. So you can modify this and create your own custom function using those 4 letters, A, B, C, and D. You don't have to use all 4 of them. You can just make it A plus 3 times B. You can do that too, and that's all right as well. Next up is the compare block. The compare block takes 2 number inputs and gives you a logical output. And so you can check whether 2 sensors are equal to each other or not equal, greater than, less than, and so on. So you could check whether 2 color sensors read the same amount. So you take the reflected light intensity here, say equal to, and now this block will give you whether or not those two sensors are reading the same value. While we're talking about the compare block, it is also good to point out that these sensor blocks also have built-in compare settings that you can use in order to kind of skip using a compare block if you'd like. And so you'll notice when I oops, sorry, I had these set up wrong. We wanted to measure reflected light intensity. But if I had clicked, if I go down into the primary setting of these sensor blocks, you'll see there's a compare section as well. That kind of lets you combine two blocks into one. You can compare reflected light intensity, and then you can click and change these settings, and the output of the comparison is going to be here. If you see, if I hover over my mouse, it says compare result. So this is the output of my comparison. So is the light sensor in port 3 less than 50? Yes or no? That's right here. Even if you use this block to do a compare, you can also read the reflected light intensity on the same block and use that as well. So that reading will always be there. And on these other blocks, you can also do compares. So on the timer, you can compare time, and then using the ultrasonic sensor or the infrared sensor, you could also do these comparisons. So that's the compare block, and also the compare feature of the sensor blocks. Last up here for the data operations palette is this range block, and this is basically like letting you do two compares at once. You basically check whether a certain reading is in between or outside of two bounds, an upper bound and a lower bound. Those are specified here, upper bound and lower bound. And so you could check whether your light sensor is reading a value between 25 and 35. And that gives you some kind of a range that you're looking for. You're looking for light values between 25 and 35. That answer is going to be here on this data wire. All right, next up is a new topic. One thing you can do with the EV3 software is pass around data using, so we talked about passing around data using data wires. You can also pass around data using variables. That's this block over here. If I bring one out, you can see what it looks like. Now I can read or write to a variable. These variables are basically storage on the EV3 itself. And so you can save numbers and then read them later on in your program. This is actually pretty useful if you're trying to configure something and you only want to have to configure that value in one place. For example, light calibration value. So if you wanted to tune your light calibration value, but you didn't want to have to change it on all of your different blocks that all read from that light sensor, you could save your calibration setting into a variable. That way you only have to edit it once at the beginning of your program. So variables. Now if you see here right now there's no variable name selected, and I can click here and I could add a variable name. All of your variables are associated with the project. So if you go here to the project properties tab and then click on the variables tab, right now I have no variables, but down here I can add another, or I could, if I had some, I could delete them. So let me create a variable here. When I'm creating a variable, I need to select what type of variable it is. Each variable, they're similar to data wires, right? So you get text, you get numeric, so this would be like the red data wires, the yellow data wires, and the green data wires. Don't worry about these array options down here. We're going to talk about those later. So let's say I wanted a numeric variable. All right, there we go. Now if I go back to my program, I can see that I can select that variable that I made up here. You got to be careful because these are case sensitive. So I can write to that variable and I can give it a value of, say, 10. Then later on in my program, I can grab another variable block and I can read from that variable. And now I can take that value and use it. You can even do the same thing for MyBlock. So you can save a variable value outside of a MyBlock and then read that variable inside the MyBlock in order to get data from one part of your program to another. If you have multiple computers, you need to be careful that your variables do get synced appropriately across. So make sure that when you bring one program from one project into another, that you also double check that the variables are defined here in the project, and double check in your programs that the correct variable is selected on the variable blocks. So definitely be careful if you're importing programs from one project to another project that use variables. All right, we have one more block to talk about, and it's actually in the next palette over, the blue palette, which is called the advanced palette. And the block is on the far left here, and it's called the file access block. Now the file access block is similar to the variable block in that it lets you save data, but there are a couple of key differences. First is that variables normally are only saved for the current program and while the current program is running. And after that program finishes, those variables get automatically deleted, and you can't control that. The EV3 program will delete them when the program is done. Files actually save permanently onto the EV3 itself, kind of like a flash drive. So that's one big difference. The other difference is that you can actually save multiple values into a single file versus a variable which only holds one value. Now you can actually get multiple values into a variable, but we'll talk about that after we talk about the file access block. So let's take a look at this file access block a little bit. Up here is where you put your name for the file. Now you'll notice this is different than variables. With variables, we had to define them in the project. With files, we just type whatever name we want, and it's case sensitive here. So you need to make sure that all of your file access blocks have this exact name with the exact right capital letters and everything. So that's where you put in the name of the file, and then you can select read or write down here to either read data from the file or write data to the file. So first we want to write some data to a file, and you'll see that there's a data wire plug here for the data that we want to save. Let's say we wanted to save a rotation value into that file. We just click and drag the data wire here, and now it saves whatever A's rotation reading is into this file. You'll also notice I actually plugged in a round yellow numbered data wire into a text slot. That's okay. The EV3 software will just pretend like this number is actually a text value. So you can do that, and you can also do that with the touch sensor or with a logic plug. You can plug it in here to the text slot, and it will pretend like this logic wire, this green triangular plug, is just a 1 or a 0. So let's say we did this, and like I said, you can actually copy multiple values to a file. So let's say we did it 2 times. So we saved this value twice. What's it going to look like? Well, I'll pull up a little comment here to demonstrate. So when you look at this file on the EV3, if you bring it onto your computer, you can upload the file if you plug your EV3 into your computer, and then down here at the bottom you can click on the file and click Save to Computer. And then if you open it on your computer in something like Notepad or any basic text editor, you'll see, let's say we wrote the values 10 and 20, you'll see them show up just like this in the text file. And so the way this works when you're trying to save multiple values to a file is that they just kind of stack up like this. And so that's what it will look like when you open that file up. Now let's say you wanted to read that file in your program or in a different program. So you'd type my file, and then you'd say read numeric, because we actually saved numeric values. The first time you go to read from that file, it's going to read this value 10. And so there's this concept of a file pointer. And at the beginning, the pointer is at 10. Now, after you have read once from the file, the pointer automatically moves down to the next value. And so then the next time, if I had another read block after this one, the next time I would actually get this 20 value. And then the third time I would get 30. If I tried to read it again after that, because the file pointer is now at the end of the file, you just get a default value of 0 over and over again. But what if you wanted to read that value 10 again, or any of those values for that matter? Well, it doesn't entirely seem like this would work, but if you use this close setting, it actually resets the file pointer back to the beginning. That's what it does. I know it doesn't sound like that's what it would do, but that is what it does. So I could read the value 10 and then the value 20 and then close the file, and then the next time I have a read, it would be back at the beginning. So I would be reading from number 10 again. So that's how it works for reading. And also, you do need to have one of these close blocks at the end of your file or at the end of your program if you want to make sure that your values are saved properly. So that's another, there's two reasons to use the close setting. One of them is you need to use it at the end of your program to save your values properly. The other reason is if you wanted to reset this pointer to the beginning. So that's what close does. And then you can delete as well. You can also delete the files manually down here in the bottom right when your EV3 is plugged in. So that's the file access block. It's very useful if you're trying to save calibration values in one program, that's your calibration program, and then read those calibration values that you recorded in another program. And it's also useful if you wanted to collect data in an experiment and then upload that data to your computer. Then you can pull it into Microsoft Excel and make plots. It's also really good to show plots like that to robot design judges. So if you do that, definitely make sure you include it in your robot design presentation. And it's also useful for just saving multiple values into a single location. The last major topic here is arrays. And so back when we were talking about variables, and I was creating this variable, you saw that I could make something called a numeric array or a logic array. So let's go ahead and make one of those and see what it looks like. So if I say read numeric array, my array, there it is, and you'll see it's a new type of data wire. It's thicker and it has a double circular plug. Arrays are essentially a variable that saves more than one value. Very similar to a file. A file let us save multiple values in one place. An array lets you save more than one value in one place too. So you could, for example, have different light sensor calibration values for your different sensors saved in an array where the slot in the array corresponds to the light sensor port number. So how do we use arrays? Well, there's a block that I skipped over intentionally earlier called this array operations block. And here you can do things with your arrays, such as read the value at an index. Index means a slot number, essentially. So arrays have multiple slots, and there's the first, second, third slot, and you can read the value in that slot. That would be read at index or write at index. You can put a certain value in a certain slot. And then you can also append, which basically means add a new value on the end of the array. And so if I plug this in, so let's say we wanted to read at a certain index, I would plug the array in, and then I would say what index I want to read from, and then that individual value comes out here. And this is just a normal data wire plug. You guys have seen this. So I could say read from the first slot. Here here it is. Here's the value. So this array, and if I wanted to actually write to it first, I would write to my array and I would give it some values. Let's say 10, 20, 30. So now this array has 3 values, 10, 20, and 30, and I can read each one of those separately using this read at index. It's important to note that these arrays start from 0. So index 0 is actually this value here, 10. And index 1 is actually 20, so on and so forth. So definitely keep that in mind when you're using arrays. Another actually very useful feature of arrays versus files is arrays are good if you need to read the values in multiple channels. So you know how we split the channel in the Programming Basics webinar? Well, if we needed to read from multiple channels and we were trying to do it with a file, that problem would be that based on which one got done first, that file pointer would have moved potentially in an unpredictable way. With the array, because we tell it exactly which index to read from, it doesn't matter which one of these channels gets done first. We can still make sure that we're reading the second item consistently. So that's one important use for arrays as well. Arrays are variables, and so they are also deleted at the end of a program. The only thing that ever stays after the program is over is a file. All right, that's all the topics we have to cover. Now I'm just going to go over a few examples that use some of these ideas. My goal is not to give you guys all the answers, but to at least give you kind of like some ideas and some starting points for what you can do with all of these new blocks and these data wires and all these different things we've talked about. So the first example I have is average the value of 2 light sensors and display the averaged value on the screen. Well, why might you even want to do this? In FLL sometimes you want to follow lines, but it can be advantageous to have a bigger view for your light sensor. One way to have a bigger view is to take 2 light sensors, put them next to each other, and average their value. That basically turns 2 light sensors into 1 mega light sensor. And so let's say we wanted to test this and see if we would get better readings. Well, we can make a quick program here that will take the 2 light sensors, average their value, and display it on the screen, and we can just run that program quickly and look at that value. So, first thing we need to do is read our 2 light sensors. So let's say they're in ports 3 and 4, and I'm going to measure the reflected light intensity from each one of them. And I wanted to average that value, and so in order to do that, I need to add them up and divide by 2. I could do that with 2 math blocks, an add and then a divide, where I take this one and I divide by 2, and I add these 2 light sensor values up. That would work. Another way to do it would be to use that advanced setting on the block and put a plus b divided by 2. So this would work. Now we have the value, the average light sensor value here, and we want to display it on the screen. So we just grab a display block. We need to say text. We need to make this wired, and we will display that text on the screen. There we have it. And now to make this program a little more useful, we should probably put it inside a loop so that it keeps running and we can move the robot around and we can see what that value is being displayed on the screen. And there you have it. That's the first example. We can average 2 light sensor values and display that on the screen. The next example is create a line following my block with a variable input that tells it which side of the black line to follow. So you guys created a line follower as part of the labs for the Programming Basics webinar. Now we want to make that a little bit more sophisticated by allowing an input of follow the left side of the line or follow the right side of the line. Now there's two ways to do it. We can do it with a variable. We can also do it with the parameter on the my block. I'm going to do it first with a variable. So first step is to create the variable. Let's add a new variable. This one is going to be of type logic because the line has two edges, left or right. And so I'm going to create a variable called left right edge. And now to help myself out, it might be good to type a name here like that, left right, true false. That helps me remember that left is true and right is false. Okay. So I've created my variable left right. Now I need to make a simple line follower, and I'm just going to tell my line follower to go until a touch sensor is pressed. Of course, you would want to make sure that this goes for whatever makes sense for you. And we want to compare reflected light intensity. So if it's less than 50, that would be seeing dark up here. Let's write the software for our true setting first. So that was follow the left edge of the line. So if we are seeing black, then we need to turn left. So let's do -50. And otherwise, +50. Okay, so now this right here is a line follower to follow the left edge of the line. But what about the right edge? So we're going to need to read that variable and essentially add another possible case here. So I'm going to change this to read logic, and I'm going to pull in my variable read. There it is, left right, true false. Plug that in here. Now remember, we wrote the code originally for the true setting, so I'm putting that up there in the true section. And same thing over here. Okay, and if we wanted to follow the right edge of the line, what would we do instead? Well, it's just the exact opposite. So I can put another move block down here, and I can make this one +50, and then we'll put another one here, -50. All right, there we go. So now that we have this, we want to go ahead and put this into a my block. Follow line. There it is. And if I wanted to use this my block, I need to remember that beforehand I have to set this variable. And it's, let's see here. We want to write a logic one, left, right. So I need to make sure I write it to true for following the left side or false for following the right side. And so I just have to use these two blocks next to each other every time I want to do that. So another way to create this program would have been to use a parameter on our my block instead of using a variable input. So how would we do that? Well, I'll just go ahead and open this my block. So let me copy it over back from the other program. And now I'm going to create the my block again. This time I'm going to add a parameter though. Then I'll click on this parameter setup tab and give it a name. And our parameter is of type logic. Okay? Then I click finish. Now I'm in the my block. Now you'd think that probably what you'd want to do then is to drag this parameter and plug it in here. But if I do try to do that, you'll notice that the program doesn't let me. It doesn't let me drag this input parameter into my loop and my switch. And even if I wanted, I could try and drag this here, but you notice it's grayed out and it won't let me access it. So, in order for me to actually transfer my data from my parameter in, I'm going to have to use the variable inside my own MyBlock. So I'll just write the variable from the parameter to the MyBlock, like so, or to the variable, like so, and now it will read the variable value which it gets from the parameter. Simple enough. So now if I go back to my program and I have follow line 2, I can actually just change the value here by clicking true or false. All right, so that's that example. Last up, we have calculate motor speeds for 5 seconds and write the values to files every 0.25 seconds in order to get a total of 20 values. So we want to read the speeds of our motors. Why might we want to do that? The Lego motors, as you may have noticed, tend to they're not all perfect and they're not all exactly the same. A lot of times your robot doesn't exactly drive straight. So in order to overcome that, you can test your motors and see which ones are the closest to each other and then use those as your 2 drive motors. So we want to read the motor's speeds. So in order to get speed, we need to take the distance that the motors have moved divided by a small amount of time. And so in this example, we're going to read the speed every 0.25 seconds. So we'll read motor B and we'll read motor C. And we need to divide it by the amount of time that has passed. So I'll use one of these timer blocks. Now, we looked here at this timer block. It says elapsed time. And if you're not exactly sure what unit that is, you can always go up here when you've clicked on the block, click Tools, and then click, Help, and then click Show Context Help. And now here, if I click on this block, it says elapsed time, numeric time in seconds. So this is in whole seconds, but you do have decimal point value. So we want to figure out the speed, and speed is going to be distance traveled divided by time. So I'm going to make this a divide, measure time. There, so now I have the speed and I've calculated it here. That's the speed for B. We can do the same thing for C. And I can actually drag this one over and reuse that read block. All right, so now I've got the speed for C right here. We wanted to save those in files so that we can read them on our computer later and plot them in Excel. So I'm going to put 2 files, one for motor B speed, and another file for motor C speed. We're writing to those files, and there we go. So this is one instance of it. We wanted to continue reading the motor speeds over the course of 5 seconds. So we need to put all that in a loop, then loop for 5 seconds. There we go, 5 seconds. The other criteria was we only wanted to read the sensors every 0.25 seconds. And so I'm going to put a little wait here for 0.25 seconds. One last thing we need to be careful of. Remember how I was saying that these read blocks accumulate over the entire course of the program? We're going to need to reset those after we've read from them. So at the end of each loop, we need to reset. B. And C. And we also need to reset the timers, or sorry, just the one timer, because we're using the same timer for both. There we go. Reset timer 1. You might wonder why I didn't just type in a 0.25 here, which you could definitely do, but by reading this timer and resetting it over here, you're going to get a more exact value. Even with this wait block being 0.25, sometimes it's like going to be 0.24, sometimes 0.26, and so it's not just typing 0.25 here doesn't guarantee that it's going to be exactly 0.25. So it's good to use this timer here to get a more precise reading. Then at the end, we need to make sure we close out our files. If we don't close out the files, they might not save properly. When you're doing this, you need to make sure you type the file name exactly the same here as you did over here. Definitely double check that. Otherwise, you're going to, be operating on a different file. Then last up, I suppose I need to turn on my motors in order for these speed values to even get any useful data. So let's turn on the motors. Turn on B and C, good deal. At the end of the program, we'll turn them off. All right, and there we have it. This will turn on the motors, read the speed values for 5 seconds, and then save them to files, and then turn off the motors. And then we can read those values, and we can import them onto our computer, and we'd see, some text files that look like this with a bunch of values. We can put those into Excel and make charts and show it to the judges and let them know that we ran tests to figure out which motors were the most consistent motors. All right, so that's all that I've got for this seminar. I hope this has been useful to everyone. Just a quick recap of what we covered. First, we talked about data wires and what they are. There's 3 different colors of them, and those correspond to the 3 different types: logic, number, and text. For the most part, we just use logic and number, though. And then we talked about these different sensor blocks and how we can use them to read sensor values. Next, we talked about the data operations blocks, which we can use to do operations on the values that we've read from the sensor blocks. We talked about variables, which is a way to transfer data from one part of your program into another by saving it temporarily just for that current program. Last, we talked about files and how we can use files to save multiple values into a certain spot on our EV3 and then upload them to our computer in order to use that data. We also covered arrays, which are a special type of variable that can store more than one value within a single variable. I hope this was useful to everyone. Again, if you guys have any questions, always feel free to contact me via email, and I wish you guys all good luck this season.